Welcome to Homework Lib.
So here we have these three sleds and it is being pulled to the right here, and the floor here or wherever the sled is present, that is frictionless. So assuming this force with which it is pulled is 125 newtons, we need to find out the acceleration of these three sleds. Let us say it is A, and we need to figure out what are the tensions in this rope B and rope A. So let us say tension in B is dB and tension in A is dA. So these both needs to be computed. So acceleration can be easily computed. Here we will just consider the net force. The net force is 125 newtons, and the total mass, that is the mass of the system, is 30 plus 20 plus 10 kg. So this comes out to be 60 kg. So we use Newton's second law of motion, that net force is equal to mass times acceleration. So we put the values here, we get 125 equals to 60 times A. So solving this will give us the value of acceleration of the system, that is 125 by 60. So simplifying this will give us 25 by 12 meters per second square, and this approximately comes out to be 2.08. So I'll take it up to 1 dp, that is 2.1 meters per second square. So this is the acceleration of the system we have figured out. Now to compute the tensions, what we will do, we will observe closely the free body diagrams of the three objects. So let us say first I consider this object 1. So on object 1, a force of 125 newtons is acting to the right, and this is moving with the acceleration that we figure out now, that is 2.1 meters per second square. And the tension acting in the rope here is TA. So here we can figure out this TA. So we'll apply again Newton's second law. So since this sledge is going to the right, so 125 minus TA will be the net force, and this will be the mass of this object 1, that is 10 kg, times the acceleration. So if we solve this, we get the value of TA, that is 125 minus 21. So this tension in A comes out to be 104 newtons. So similarly, we figure out the free body diagram of this object 2 or object 3. So to simplify or to ease out the calculation, we take the free body diagram of this object 3. So on this 3, only tension is acting, and that tension is TB, which is in the string B. And due to this tension, it is seen to be accelerated with 2.1 meters per second square. That's what we found for the system. And since the system is, the objects in the system is interconnected, so all will have same accelerations. So here we again apply Newton's second law, that is the net force as mass times acceleration. So net force is TB, mass is 30 kg, so we put it here, and the acceleration that we figured out. So this gives us the value of the tension in string B as 63 newtons. Okay.